Hi, I'm Landis. Welcome to my studio.
Start with cutting up a lot of the scrap that we have. It's just a fine silver casting grain. .6, so that right there. So we'll put that in the cast and we'll melt it actually twice. We're not really looking for a melting point, we're looking for a flow rate, because what I need to do is get it melted down and liquid enough to keep liquid while I cast it. So I actually set my temperature as high as this will go, which is 2012. In terms of the scrap, I like to get the scrap going first and get it liquid, because if you start with the copper, it doesn't quite melt properly. It will melt into the silver if the silver is already melted. Make sure it fits. Okay, so that first batch of scrap is already melted down. You can see that we're going to liquid there. It's hard to see into that orange, but you can probably see it bubbling. So we'll go ahead and add this silver and copper. And then again, we wait. Just keep adding this scrap. We got a full. Don't reach in and grab that. I know this from experience. Just keep bringing it in. Since we made fresh sterling, I like to cast it a couple times, melt it and recast it a couple times to make sure it gets mixed real well. So for the sake of that, we're not going to worry about the shape of the bar. We're just going to cast it into this brick mold. What I'm doing now is I'm actually sweating the cast iron, and what I mean by that is when I put heat on it like that, the condensation around it is going to come off and it'll appear wet for a second as it condensates, and then that's going to evaporate as it heats up, because there's a danger in casting liquid metal into cold metal, because that condensation can form quickly and actually explode. That'll be good on that. And then I coat the surface of it. In this case, I'm just using acetylene, and I'm putting a nice thick layer of carbon deposit on there, and it's going to keep the metal from sticking to the cast iron. Not real concerned about the quality of the cast in this case, because we're going to remelt it anyway. But this is what you came here to see right here. Here we go. Give it just a second to cool, enough to turn solid. Knock it right out of there. Sound effects. Oh yeah. All right, we're going to get this ready to cast. We've got plenty of temperature. We're going to be pouring into this. It's just called a book mold, and just kind of clean it out a little bit here first. And again, similar to really anytime you're casting, you want to make sure there's no condensation, any water, any liquid around anywhere. So what we're going to do is we're actually going to hit it with the propane torch and warm it up and get it ready for casting. When we're doing production runs, you only have to do that right when you start, because once we cast material in there, it's going to be super hot. So if we're doing production runs and doing multiple pours throughout the morning, throughout the day, then it's unnecessary to keep sweating the mold. It'll stay plenty warm. Again, I use the acetylene. I just use straight acetylene, no oxygen. And you can use, people use different things. Mold release, tallow, Vaseline works pretty good. It's a little flammable. I have found the carbon deposit from the acetylene to be super heavy and thick and slippery. And we're just gonna line that up. I'm using just welder's clamps, just adjustable vice grip C-clamps, as opposed to the threaded style, just much quicker. I want to always make sure that it's nice and tight on the bottom because you will get spill out, and you want these clamps just as tight as you personally can manage. I dust the top again just to make sure that my entrance is nice and slippery. And then I've got it just in a baker's tray, you know, an oven tray. But I'll actually coat the entire tray with that acetylene as well. That way anything that spills doesn't get stuck on that steel or anything. It'll puddle up and not stick to that tray. Don't forget your safety glasses. I almost did. Some of you may prefer a face shield if you don't have the experience you need to be an idiot. But these glasses will work. The last thing you want is a splash of hot silver in the face. Now the fun part. And I can tell that it's already hard enough to kind of do this awkwardly so you can keep seeing it, but there's a cast bar. There we go. Nice big bar of sterling. So just gonna, when it comes out of there, you got this flashing. But we just take a shear and clean up all the flashing that we can. And all these scraps, you know, you save them and we just throw them back in. That's one of the cool things about manufacturing and fabricating with precious metals, is that we can just recycle everything. So, pretty cool. I just got a heavy-duty Scotch-Brite wheel on here. You know, you can use a wire wheel. You can do it by hand, sandpaper, Scotch-Brite, whatever. But what we're going to do is we're going to clean this bar up before we run it through the rolling mill, so that all of this schmutz, that's a technical term, that's on the surface here doesn't transfer over to our rolls. We want to make sure this is just as clean as we can get it. So this wheel is going to clean all that off. I'm actually going to kind of take there's some of these sharp edges and stuff, but I'll just run it through there. You'll be able to see that. So just using this one as a knockdown, and I take really small bites. So I'm really kind of just trying to get it down to a thickness that'll fit down into my finishing mill. With sterling, it's important to constantly keep it annealed. I can't stress it enough, because what happens is the part will start to crack. You'll get cracks and crazing and all kinds of trouble all over the material. It won't stay flat. If you don't keep it annealed and keep it soft while you're working it, it's just a total pain. So what we do is we're actually just using a propane torch to keep this. We're gonna heat this up red hot, and then we're gonna quench it in an annealing bath that has some acid.
2 hours later.
That plum color is plenty. The nice thing about precious metal is it conducts heat throw it in this acid. I'll take this over to the wire wheel and we'll clean that surface up again, and then we'll hit it in the rolling mill again. Okay, so depending on what kind of product you're making in your rolling mill, it's really important to keep your rolls as clean as possible, because you're going to get grease and deposit, and as they sit there when you're not using, there's dust, and you don't want any of that on there, because anything that's on that roll is going to get imprinted or pressed into this surface. So you do want to try and keep it as free as debris as possible. So what I like to do is I just take a little bit of acetone on a paper towel, it's soaked, and I've got a paint scraper, a palette knife, and I turn the mill on. I've got the mill closed to where this won't fit through there. This is the exit side of the mill. Don't ever do this on the entrance side, because all it's going to do is suck it up in there and you'll have all kinds of problems. So what I'm going to do is I just have that acetone on the paper towel, and I can place it and I can push pretty hard and just let the rolls clean themselves. And you see just the dust and grease that collects over time. It wasn't this mill in particular, it's one of our smaller rolling mills. I was actually working with breaking down material to get it small enough to fit into the caster again, and kind of just not paying attention. And the material, many of you who work with rolling mills know that the material can wave a little as it's going in and out. And as I was feeding the piece in, I was too close and it waved down and it grabbed my finger, and it actually tore and pulled my finger into the rolling mill. You can see my pointer finger there is severely distressed. It's my Frankenstein finger, and it actually took about 3 surgeries to put it back together, and that's only one of the finger injuries I've had over the 20 plus years doing this. They call me Fingers because I still have all 10. Now that it's all cleaned up, we'll just open it back up to the thickness that we get to start here. So, and we'll just start the process of knocking this down. Every time it passes through there, we turn it down a little bit. It's knocking down about 20 thousandths in each pass. Oh, this is kind of cool. To start, when that bar was cast, it's already a little longer. It was probably 8 inches when we started. And you'll see by the time we get to the thickness we need, you'll see how long it gets. See, I'm actually taking the time to flip it each time too. Because what's happening inside the bar is there's a grain structure in there. Like under a microscope, it would look like oatmeal. And what it's doing is it's elongating all of that grain and stretching it all out. And if you keep doing it in the same direction, you're going to get, like on a molecular level, literally, the crystals are going to be all pushed in one direction. And when you flip it, each time you go through, and what you're trying to do is just make sure that as you're running it through there, that those crystals are rolling in all kinds of different directions. Because what you want is a nice consistent density as it goes through. And it's that will help relieve some of the cracking that can occur and things like that as you move through the further processes. You can see we're already to a foot off of 8 inches, so we got a long way to go. I'm actually going to anneal this again, because you can see I'm starting to get some deformation in there that is a little bit more than I like. And so I'll anneal it, clean it up, and we'll keep going.
One eternity later.
Okay, so I've already rolled this down and annealed it, cleaned it several times, even to the point where I cut the strip in half, because it gets too long to handle. And you can keep it that long if you want, but just for convenience, we cut it down. So we're already to about 4 feet long off that 8-inch strip. We're down to about 100 thou right now, almost exactly. We're going to go down .052 inches, or we say 52 thousandths. And you know, that started off as a really thick strip, and we go down really thin, and it's really just for convenience so that I can get it in one bar and move it a lot. But from a purely technical or engineering perspective, when you're rolling your precious metals, your silvers and stuff, if you want to get a consistent density and a consistent grain structure, so that when you're annealing and working the material, and it stays, you know, so you can get rid of voids and inconsistencies within the material, you want to aim for at least 40% reduction rate. So you want to start at a thickness and reduce that thickness down by at least 40%. Obviously, we've gone from, I don't know, 3/4 of an inch all the way down to .052. So we've gone plenty over 40%. But right now we're going to head, I know that this wrench thereabouts gets me about 20 thousandths. I'm at 100 thousandths now. So I'll run it through there a couple times until I get real close, and then I'll start measuring with my micrometer to make sure I get to the exact thickness that I need. So I'm probably somewhere around 60. I'm actually at about 65 and a half right now. I'm aiming for 52. Now, if I was working on a coin, it's very important to get just as an exact measurement as possible because it's going to determine the weight of the piece. But what we're doing here, we're going to do a lot of handwork and a lot of trimming, and we're not after a specific weight, we're after a relatively consistent thickness. So I'm not going to concern myself so much with getting the type of tolerance I would need for making a coin or something that was going to be marked with an exact weight. So from now I know I can get somewhere around 10, I'll be real close, and I'll be able to zero in from there. I can probably hit it in this pass. So we're actually at 53. I'm actually going to be okay with that. Little heavy's not going to hurt anything because we've got some forming to do. But on this piece, I'm just going to take a little bit of a fraction to get closer to that 52. Measurement on that one. Now it's still at around 53, but I'm going to call that good. Okay, so we're going to blank this out now. I take this material as rolled because it's going to have a lot of hardness to it. If you were to blank your precious metal dead soft or fully annealed, you can run into some disformation, what we refer to as cupping. And so you can get some inconsistent blanks, you can get a lot of extra flashing, you can get just some little extra trouble when it's super soft because it's real malleable and it changes shape. So I like to do it as rolled. In this case, considering all the rolling I do to it, it's probably full hard. It's quarters, quarter hard, half hard, 3/4 hard, full hard. And you want at least like around a quarter hard to keep the blank from being disformed when it comes out. That's the air compressor. I'll just run that strip through here. We got a strip of plate in it. Again, tuning it out of the episode and see how this all gets set up. What I'll do is I'll run a few in one direction so that I can get the orientation correct. And then we'll run the strip back through so we can get as many out of the strip as possible. We refer to that as webbing. We can just cut it down, remelt it, start all over again. They're just passing through the punch into this bucket. And, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, that's the starting blank. I've just got those blanks that we blanked out, and I annealed them. What you're doing when you're annealing is that grain structure gets all elongated and mixed up and changes all the shape. And when you anneal it, you're actually splitting all those grains into tiny little pieces. And so that's why you take all that effort of getting the correct reduction ratio and flipping the strip and making sure that all those grains stay intertwined. Because when you go to anneal it, literally, if you look under a microscope, you can actually see the grain structure in the silver, and you want it to split into a nice little fragments, nice little crystal fragments, instead of being all misshapen and misdirected. Because it aids itself in the way the material strikes, the way the material works. After annealing it, again, it just gets that fire scale and whatnot on it. So we're running through a really nice, soft, buff Scotch-Brite. Just to take the fire scale off it before we start the forming process. Not overdo it, just clean off that fire scale. So one of the key components and details of our finger picks that is different from all of the widely available mass-produced ones is the thickness of our blade is actually thicker than the thickness of the band. So the bands will have a nice thin adjustable malleability so that we can, you can form them to your finger, but we wanted to make sure that the blade itself all the way through the band was thick enough to really outperform the standard picks that are out there. So what we're doing is we're taking this blank that we took out of the punch press there, and we have a forming die that this might not transfer or be able to be seen that well on the camera, but it's already got some of the pre-shaped form in there where I was just speaking about, where the blade is thicker than the band itself. And what we're going to do is that aligns in there. It has the same exact orientation as the blank, and we're actually just going to hit that with a flat die. And what it's going to do is we're going to thin the band out while leaving the thickness of that blank, and start to put the bulb, what I would call the bulb, on the paddle of the pick blade. So it's a forming operation, a preform operation before we get to where we're putting the engraving, the embossing on the finished pick itself. And you'll see once it comes out of there, after smashing it, it's gonna create a bunch of flashing around the edge. We're gonna have to trim that off, do this a couple times to get the blank ready for the final strike. And so I'll show you that now. So here you can see it's actually smashed that and pushed that material out. And so we'll go back to the punch press. This is the exact same shape as that punch and die over there. This will fit right back into the press, and we'll cycle the press and we'll trim all of that off. And now we'll have it's thinner in the blade, and you can see or thinner in the band, excuse me, and it stayed thick in the blade, and it started to preform the blade.
All right, Ron here. We've got a little batch of death grip finger picks we're making. Now when they're pressed, the final pressing, we get flashing that squeezes out from the dies, and I have to trim this all up with a jeweler's saw and files, little emery boards before they go to the buffing machine. The metal is really thin here, so it cuts really easy. Not being real accurate because I'll trim it up with a saw, or I mean a file, after it's sawn out. And for this upper part, I can actually use a tin snip and just trim this off a little bit. Can't do it on the inner part because it's too easy to mangle it up in there. And just I'll continue with files. Clean that up. Just continue that all the way around until the whole thing is trimmed up. This is one of two styles we've got now. It's pretty popular. I find the younger players like this death grip design with the skull in it. Kind of has that sort of a heavy metal kind of look to it. All the shredder banjo players like these. It started out just with the name. I came up with a name for the inner gripper teeth, and man, they really death grip. They hold on to your finger like a death grip. That got my mind going. I thought, oh, that looked cool with a skull on it and with the name Death Grip. So yeah, it's just one of those things, and it kind of happened pretty quick. I thought it was a great idea. Some people really do not like the skulls though. So we will have other styles available. I have a gospel model coming up. It'll have a cross on it. We also have an economy model coming up that I'll be showing in a little bit here. Alright, got the file work down now. I'm going to use one of these little emery boards. I got this from Rio Grande, and they're flexible. And then like got foam on the inside. This is a 400 grit, and I really like these things because you can sort of bend them around the curves. Great for contouring. You know, getting in there and smoothing these edges. So it'll take those file marks down, get them smooth and ready for the buffing machine, which will be the final finish on these. But I always like to spend extra attention to the edge of the blades. That's the business part of these picks, is where the string will be coming off the edge of these. So I don't want any kind of burrs after I get done here. They will be annealed one last time, and that annealing, the softening the metal with the heat, it will make the picks last longer for one, because when you're playing them, you're always adjusting them, squeezing them in, and adjusting them, and you know, your finger will swell or shrink depending on the climate or the temperature that day. So they get, normal picks will fatigue and break after a while. This makes them last a little longer because the metal is dead soft then. So they can be bent back and forth a lot without fatiguing. And also it will make it softer so they can be formed better. So this is about ready to go. Now I'll take this back to the other shop and anneal it one more time and get back and we'll show the shaping. Okay, so I've annealed it. It's really soft and bendable now, and I have to start at the ends because it's that last little bit of the curve that's kind of hard to get. So I made a special pair of pliers just for bending the ends. It's the end bender to end all end benders. And if you can see it, I put a little piece of cloth in here to protect it so I don't scratch it. And I don't try to bear down, I just trap it there a little bit and just start that end curve there. And do it to the other side. And now I'll take it to the pitch block over here, and with a big round punch I'm just gonna get that spoon in nice contour there. Doesn't take much. I just want to get the bend started here a little bit and you know, round out that spoon a little more contoured. So that's the start of it. Now I put it in here. This is silver, so I'm going to mark this 925 on the inside. And also with this big round thing here, I can get it started just by pressing it in down to the bottom there. Now I'll use my 925 stamp, and that will help actually form the blade as well. So it's got a little 925 stamp in there. Now I get to use my new tool, which I really like. I got this from Rio Grande. It's $195 for this tool, but it's awesome. It's got, it's for bending rings and flat bands and so forth, but it's got a little protective liner around here to keep from mashing the teeth in. And I can just basically just put it in there and squeeze it. It's not automatic, but it does pretty well. And I just sort of work it. I don't just put it in there and squeeze it. I kind of work it around a little bit to get a nice round contour. Now what I like to do is kind of just by hand just sort of widen it out in back so it's sort of a tapered hold. It fits your finger just right. I always kind of test fit them to see how they feel. That feels about right. Feels pretty good. And now sometimes I'll take a file to this blade end. If I see there's not like a real nice contour to it, there might be a little bit of a kink in, I'll try to file that out. But this one's shaped really well. It's just going to need some little emery cloth to smooth out the contour. And also this takes off any fire scale that might have happened in that last annealing. And even the back edge, I like to polish this back edge here and get a really nice finish all the way around here. So there's no burr in there to mess with the tone. It's all about the tone. These thick silver blades are awesome for that. And pretty much ready to go to the buffing machine now. Okay, we're ready to buff. This is the buffing wheel. Turn it on. Go triple E. Alright, it's got the rough, no, it's not rough, it's the pre-polish actually. And now I'll take it to the rouge wheel to clean off triple E. If it's got any residue, you don't want to contaminate the rouge wheel with it. So it's better if you're doing a batch, clean them between the wheels. That way you can keep this rouge. So from there, I'll put some oxidation in here, to put a patina in it. We'll let that set, and then the final finish will be done with hand buffs. The bands don't need to be shiny like the blade, so we'll put more of a matte finish to bring out the contrast in the patina. All right, I forgot one step. Before I put the patina on, I want to put it in the ultrasonic cleaner to clean off any of the buffing residue, and this will help the oxidizer. But I put them in that way so it vibrates ultrasonically, so if I put the blades down on the basket, there's a chance that they could scratch those blades. So get the basket loaded, it goes in here, and high-tech control knob, turn that on. Leave that on for about 3 or 4 minutes and they should be clean. Alright, they're done now, and we'll see. Steaming hot batch of death grip picks. Now I'll put the patina on these and they'll almost ready to ship. Alright, so now I'm just putting on the patina. I just use a little of this Black Max. I get this from Rio Grande. It's not paint. This actually changes the color by oxidizing the metal. I just brush a little on where I want it. Try not to get any in the back. Sometimes I get some in the back, we have to sandblast it out. Should be doing this in a better ventilated area. I'm usually only doing just one little tiny spot at a time like this though. So anyway, now just let those dry and we'll rub them off and they'll be ready to ship. Okay, and the last step, I just rub off the highlights using a sunshine satin cloth, and it's got a fine abrasive on it. I can take that oxidation off the high points. Leaves kind of a satin finish on the band. Alright, and there's a finished pair. It's ready to be shipped. One more thing, I gotta test them.